the quadratic formula is used to find the solution of a quadratic equation. Alright, now when we use the quadratic formula, it must have an equation that is written in standard form. Okay, so I'm going to write that down here. Again, this only works on standard form, not on vertex or factored form. So with the quadratic formula, what we need to do is identify our a, b, and c values and plug them into this equation. Now there is a quaint song where you can sing this to the tune of Pop Goes a Weasel. I will spare that from you here and include it a little later in the Prezi. So our first step is to identify our a, b, and c values. Our a value is the number that's in front of x squared. So in this example, our a value is 1, because there's 1x squared. Our b value is the number that's in front of the linear term, or just the x. Now understand, if this had said minus 4x, this b would be negative 4. Okay, so they kind of carry the sign with them, like whatever's in front of it. Okay, so I have a, b, and c. So now I'm going to go ahead and I'm going to take kind of my formula and I'll be plugging those in. So I will always write the black parts of this formula out. But where I put the a, b, and c, I'm just going to put some parentheses, and we fill those parentheses with whatever values we find in our equation. Now the quadratic formula is kind of like a sledgehammer. Okay, it will find the answers to any quadratic formula or any quadratic equation that you have. It'll find the real answers, it'll find the imaginary answers. But that being said, the quadratic formula is a little bit of work. Okay, it requires a lot of effort to actually simplify. So most scholars will tell you to use the quadratic formula kind of as a last resort. You always want to see if you can factor it, or if you're quick at completing the square, try to complete the square. Because as you can see, it's a pretty long formula. Alrighty, so now that we've done that, I'm going to start kind of by cleaning some stuff up. Okay, I usually take this radical and solve it to the side because I don't like having to write a bunch of stuff. So that's what I'm going to do here. Now this radical, the value that's under this radical is something called the discriminant. I'll be describing that in a little further part of the Prezi, but the discriminant is used to estimate how many solutions you're going to have. Alrighty, so here's my radical. So I will always start by squaring my b here. So 4 squared is 16. And then I'll multiply together this part. So 4 times 1 is 4, times 3 is 12. So this turns into the square root of 16 minus 12 is 4. And the square root of 4 is 2. So all of this part right here turns into a 2. So what that does to my equation then is I have x equals negative 4, so I can just drop those parentheses, plus or minus the 2 that I just got, because we simplified the parenthesis, or the radical, all over my 2 times a, so 2 times 1 is 2. So then I'm going to simplify this again by dividing each of these terms by 2 if I want to, or I can split it into 2 equations. I'll split it into 2 equations first. One where there's 4 plus 2 over 2, and one where there's 4 minus 2 over 2. Okay, that's what that plus or minus does, is it breaks your equation into two equations. So then here, negative 4 plus 2 is negative 2, divided by 2 is negative 1. And here, negative 4 minus 2 is negative 6, divided by 2 is negative 3. So for this parabola, I know that I am crossing this x-axis at negative 1 and negative 3. So here and here. Now, what's nice about this is if I wanted to continue to graph, there's some easy information I can grab, right? So remember from the earlier part of this presentation, your c value is your y-intercept. So I know that on this y-axis I'm going up by 3. And I know that there's an axis of symmetry halfway between these 2 points. So I can reflect this across the axis of symmetry, which gives me negative 4, 3. And because I have that axis of symmetry here at x equals negative 2, I can then find my vertex if I wanted to, okay, by plugging in a 2 into the function. I'll go ahead and do that so I can finish my drawing. So f of 2 is 2 squared plus 4 times 2 plus 3. Okay, so 2 squared is 4. 4 times 2 is 8 plus 3. Oh, I'm sorry, that should be a negative 2. So this is a positive 4. And this will be a minus 8 plus 3. So that gives me negative 4 plus 3 is negative 1. So our vertex is here at negative 1. So then I can just draw that parabola if I wanted to right away. But really, the main purpose of this is that quadratic formula, which finds those 2 intercepts for us right away. And remember, under that radical is your discriminant, which we'll cover the next portion.